So looking at arithmetic sequences, there's arithmetic and geometric sequences. The arithmetic kind are the ones where you just add a number or subtract to the previous term, right? You use adding. This is like a common difference between them all, right? And so a geometric sequence would be where you multiply to get the next term, right? You take every previous term, multiply by 3. That's geometric. If you need a calculator, you should get one. Either way, okay? So the arithmetic kind, okay, these are more like the linear functions, right? But you remember when we graph it, it's discrete. So what does that mean when you graph these? What do you not do when you put all your points on there? Connect the line, right? Because there's no in-between values. It's not, right? So it's discrete, which means it is a non-continuous function. And so let's say like every term is found by adding 3 to the previous term. Doesn't that sound like slope, maybe? Yeah. Right? Keep going up by 3 every time you get to the next term, okay? But they're non-continuous. So arithmetic are when you're adding or subtracting only, okay? So here's an example. You got Evan saving money, buy a new toy. Evan, Evan? No. I guess with a I. She already has $12 in her account. Does that sound like starting point, or if we're looking at it in sequence terms, it would be the A1, like the first term, which is kind of like the B in y equals mx plus b, no? Okay. She gets an allowance of $4 per week, and it looks like she saves 3 of it into her account. So is there like a change here? Plus 3. Is that kind of like slope a little bit? Right? So we have a first term, A1, which is 12. I guess she's going to, so the 12 plus 3 that week is 15, yeah? I kind of did that on the homework. I wish you were more clear about that. And then each other term is found by taking the previous term and doing what to it? Adding 3 to it, right? So the weeks are just the place in line for the sequence, right? So in week 1, she got 15, 2, she's got 18. The third term would be what? 21, and then, yeah, 33, right? Okay, all in dollars. That's not too bad, right? So again, it's like y equals mx plus b. It's an arithmetic sequence, right? The first term, A1, is the b, and the slope, m, is like the rule for getting the next term, okay? Yeah, so let's go down to part B. Let's write a recursive definition.
Why is that 2 lines on the thing?
Well, that means it doesn't, it kind of skips to 14. Feel like it doesn't start at 0. Remember those things? Yeah. We're down here, though, part B. They're doing the down thing again. So let's write a recursive definition. So recursive, remember, unlike explicit, you state what the first term is, right? Comma, then the rule. So what's the first term, and how do we identify the first term in our notation?
15.
What? Well, I want to write out the actual recursive definition. So I can't just write, yeah, I got to write A1. The first term is, what is it? 15? And then what's our rule? So we'd say what? A sub n equals what? 3?
Equals 15.
So every time? So this sequence is just 18, 18, 18, 18? Yeah. Okay, good. So don't we take the previous term and add 3? How do we state the previous term in this notation, guys? If n is the term we're looking at, how do we state the previous term? A sub n is A sub n equals A, previous term, what? fix that.
Plus
Plus 3, so there's your recursive definition, right? Tells you the first term, and then it tells you how to get all the following terms, right? It's just how to get the next term is just the previous term plus 3, right? Let's go back up to C. They want to know what's wrong with the graph of the sequence.
it's not going up by 3. And it's also.
I think it is going up by 3. But what's the problem?
Yeah. There's a line.
Yeah, why not? Why shouldn't there be a line?
There's
Because, yeah, the line indicates what?
that there's like something.
We call that continuous function, right? Indicates a continuous function. Right, that there are in-between values, are there? Okay, so we'll just say, but there are no, so there's no, like, half weeks, right? There are no in-between values. Right, remember we call this discrete. Okay, one to the next, so keep counting. Place in line. There are no half places in line. Got it? Right. So now they're gonna, oh, what's this part D here? Oh, so now the explicit formula. Right? Does this look familiar? Does this look like y equals mx plus b? All right, well, let's see if he did this correctly. Will it generate the terms that we need? So we see up here we have the table, right? First term is 15, then 18 and 21, right? So we should be able to plug these n values up here in for the n down here, right? So let's see if it matches up with the table. A of 1 would be 3 times what? 1? What does that equal? Huh? 18. Is that our first term? It doesn't even give us our first term correctly. It's off a little bit, isn't it? Right? Anybody think of a way to fix this, maybe? So anyway, this is not correct. Maybe instead of using n, use what, maybe? If this gives us 18, how could we fix the n to make it give us 15? Any thoughts? Doesn't this make us off by?
0.
Right, but we need to talk about the first place in line. Instead of using an n up here, like this part of it, what could we use instead of the n?
Could you replace it with like a number?
Use what?
Could you replace it with like a number?
Well, not really number. Right? So n is like the, so they're saying that the nth term. Anyway, what they gave us an 18. It gave us the second term, didn't it? Using the n. But if we wanted the first term and not the second, instead of n, we should have thought about what? Don't change the n. Keep it to n. And what? Not sure what that means. Times 2? Don't we need to somehow back it up a term?
Subtract.
Okay, so instead of n, we might use what? We'll keep it as an n.
Negative n.
What? So we don't want the second term, we want the first term. So not n, but the term before n would be what? Like the previous term is what we want. I don't want the number, no. If their n is giving us the second term, we should not have used n, we should have used what to get the previous term? The previous term.
Minus 1.
Just put a -1 in there?
No, like the n sub n minus 1.
N minus 1, there we go, right, okay, right? So if the n gave us the second term, we should have been thinking about n minus 1, right? The previous term. Because that's the 15 we should have started with this, right? Okay, so that said, let's look and see, do they do it here? Oh, they don't. They will in a minute, I guess, on the next page. But anyway, let's look at the, so arithmetic sequence is you increase or decrease by the same amount, okay? Adding. And we call this increase at adding whatever, 3 or subtracting 2, right? We call it a common difference. Common difference. And we'll use a D for that. Makes sense? Yeah? So will this D be kind of like our slope that we've been learning about? Yeah. Isn't the slope kind of like a common difference? Sort of? Yeah. Okay. Let's look at exercise 2. Arithmetic sequence. That means something's just getting added, not multiplied each time. It's given by the recursive definition. What's the first term of that sequence?
-3.
-3. How do we find each following term? Each term is found by taking the what? What's this? I minus 1? What's b sub I minus 1? The what? Previous term, and then plus 6, right? So they want to know the value of what? What does that mean, B4? The which term? The fourth term, okay. So let's just list them out then. So B1 equals -3. B2, how do we find B2? Take the what? Previous term, -3, and do what to it? And what do you got? 3. Somebody else chime in here. Okay, let's find the third term, Hannah. B3. The third term, any term, is found by taking the previous term. So what's our previous term to this one? The one that came before it, and doing what? And what do you got? 9. Let's try the fourth term. What's the previous term to this one now? 9. Do what to it? Yep. And what do you got? 15. That's our fourth term. The idea now? So that's a recursive definition, right? Like, how did I get that? Right there. How did I get the second term? I took the previous term. Well, what was the previous term? Right there, -3, and did what to it? That's 6. And then for the third term, I took the previous term, which was what? Huh? Okay, 3. That's it's just right. Yeah, good. All right, so that's recursive. So we can also write an explicit formula for it, which is going to look a little more like mx plus b, but let's go see what they got here. So first of all, let's make sure we can identify an arithmetic sequence versus geometric, okay? So if it's arithmetic, it has a common what as you go along from term to term? What did I write on the previous page? It has a common between any two terms, huh? Common difference between any two terms, right? It has a common difference for every single term. right? So like if you added 3 to get to one of the terms, and every single term is found by simply adding 3 and that's it, then you have an arithmetic sequence, okay? So let's take a look at part A. Freeze the function, determine if it is arithmetic, and then fill in the blank if it is, okay? So how do we go from 5 to 9? Looks like plus 4. I like to write it down below like this, right? 5 plus 4 is 9, right? And how do I get from 9 to 13?
Plus 4.
Plus 4. Let's check these other ones. How do I get from 21 to 25?
Plus 4.
So is this arithmetic?
Yeah.
So it is. Yes, it is. So how do we find this missing term?
I-
So you do plus 4 and you get what?
17.
17. Does that give us plus 4 to 21?
Yeah.
Okay. So what is the common difference? D.
4.
4. Are you with me? Okay. Let's look at part B. Is that arithmetic? Well, why not? Looks like 5 plus 5 to get to 10, right? Well, it seems arithmetic, just adding 5. But wait a minute, does that hold up?
No.
10 plus 5. What does it look like they're doing here?
They added 5, and then they're adding 10.
What are they really doing?
Multiply by 2.
Ah, they're multiplying by 2 each time. Multiplying, not adding, right? So isn't this 5 times 2 equals 10? And then times 2 is 20, right? Again, times 2. So there's like a common multiple, right? So this would be what?
80.
So that's 80, right? So this is a no, it's not arithmetic, right? We call it geometric if they multiply. Okay, that's a geometric sequence. How about part C? Is that arithmetic?
Yeah.
What do the rest of you think?
Or no. Geometric.
It's geometric?
No, I don't know. It's subtracting.
Every time? Is it subtracting 3? So 7 minus 3, is that 4?
Yeah.
Minus 3, is that 1? Negative 5 minus 3, is that negative 8?
Yeah.
It is. So what's this missing term? Negative 2. Is this arithmetic? Huh? Does it have a common difference? What's that common difference? Negative 3. So it is arithmetic.
So the next one.
So the D equals negative 3. Right?
So if it's multiplying and dividing, then it's going to be the geometric one.
Yeah. But remember, dividing is the same as multiplying by a reciprocal, right? And subtracting is the same as adding a negative, right? Yeah. So how about part D? Do we have a common difference?
They're dividing by 4.
Dividing by 4 or multiplying by what? 1/4, is it 4? Yeah. Multiplying by 1/4, yeah? Let's try this. Is it times 1/4? 16 times 1/4, does that get you 4? What's 1/4 times 1/4? Oh, good grief. Multiply across the top. What's 1 times 1? That's 4 times 4. Okay, is that times 1/4?
Yes.
Okay. What would be the missing term then? What's 4 times 1/4?
1.
Anybody else? 4 times 1/4? 4 times a fourth. Or a fourth of 4.
8. 1.
A fourth of 4 is 1. 1. Is this arithmetic? It is not. What is it?
Geometric.
That's geometric again. So if it's arithmetic, it has a common difference, whether it's positive or negative, right? If you're just adding or subtracting, it's arithmetic. If you're multiplying, it is not. All right. So let's see here. They say stuff that's usually is less than helpful, but if not, take your time and really think about. Oh, yeah, that's okay. Anyway, so let's take a look at this sequence. We got 4, 14, 24. Let's do this. Let's set up our n up here, right? And we'll call these terms A. And so our n is a first place in line, second, third place in line, yeah? Like we did before. Does this look arithmetic? I mean, it says it is. Does it look arithmetic? Why not? Doesn't it?
It has the same.
What is that?
10 plus 10.
Isn't it just adding 10 to each term? Okay. So I would just, let's make a note here that it does have a common difference, and that's 10. Okay. All right, so A, what is the fourth term? Well, that should be, yeah. So we'll just say A sub 4 is going to equal, the previous term was 24, right? And we said we're adding 10, so it's 34. Okay? So let's see. How many times was 10 added to get the fourth term? So like if we started at the first term, how many times did we do plus 10, plus 10, plus 10? Huh? Was it? So if the first term was 4, how many times did we add 10? Only 3 times to get to this, right? So 10 was added. You guys understand it was only 3 times, right? Was it, you remember the previous page where we were off by 1 term? We don't? Back here, where they tried to give us this thing here? Yeah? And now we just realized that, wait a minute, we didn't quite add 3 this many times, right? We added 3, 1 less than we thought, didn't we? And I said maybe think of it in terms of the previous term. That makes sense. You get where we're, like the one we were just looking at as compared to this one, right? Yeah. So this one's telling us that we added 3 a certain number of times that we didn't. It seems like it's 1 less, isn't it? Yeah. What I mean here, to get to 34, we started with 4, right? And then we added 10 1 time, yes? And then 2 times to get to the third term. And then 3 times we added it to get to the fourth term. You see what I mean? We added 10 1 less time than the term we want. Does that make sense? Okay. So basically, we took A4 was found by taking the first term, which was what? 4? And then what? Plus 10, plus 10, plus 10. Didn't we? How can I rewrite that? Isn't that 4 plus, what is it, huh? 10 times 3, right? Or 3 times 10, isn't it? Either way. Yeah? Which is 4 plus 30, which is what? 34, yeah? So do you see the number of times that we added 10 is 1 less than our place in line? You getting that? Because we already started with a number that we didn't do anything to. And we didn't start doing stuff till the second term. So we only add 10, 1 less time than the place in line we're looking for. So, part B, use what you learned in part A to find the value of A10. Okay.
Can we do 4?
Yeah. Equals 4. Well, if it's the 10th place in line, how many times did we add 10? 9 times. So 4, 1 less than it, right? 9 times 10. which gives us what? 94 is the 10th term. You get the idea? We add 10 one less time than the place. Well, look at 4. If we start with the first term, with 4, how many times do we add 10? 0 times. Isn't that one less than the first place in line? So every place in line, you're adding 10 one less time than its place in line. That's what we take care of it first. Okay. So firstly, let's write our recursive. Remember, we list the first term. So A1 equals 4, and then how do we say how to find each following term? A sub n equals whatever. I want the whatever. Are we talking about the previous term? We take each previous. So the previous term is always 4 for the entire sequence. A sub n minus 1, the previous term, plus 10. Well, you guys aren't remembering the previous term is represented by a n minus 1, or I minus 1. Huh?
I am.
Okay. Now they want us to write an explicit formula for an. This is recursive. Okay? Explicit's going to look a little more like y equals mx plus b, right? And b is like our starting point, isn't it? So a sub n equals 4 plus 10 times something. 10 times the place in line? Okay, 10 times whatever place in line it was. Wait a minute. I thought it was 10 times 1 less than its place in line. How'd you find the 10th term?
N minus 1.
Multiplied it 9 times, or added it 9 times. How did we find the 4th term?
3 times.
3 times. Right? So 1 less than 4. So this should be 10. We add 10 n times, or how many times? N minus 1 times. 1 less than. You guys see that? Yeah? You know how to write 1 less than something? It's something minus 1. Do you understand how we got these by adding 10 one less time than its place in line? If its place in line is the nth place, we take the first term and add 10. So this is the 4th place in line, right? Right?
Yeah.
So we take the first term 4, and we don't add 10 4 times, we added how many?
3 times.
1 less than the 4th place. Up here, we started with 4 and we added 10, not 10 times, but how many? 9 of them. 1 less than. So we take the nth term, whatever it is, we take 4 and add 10. What's 1 less than the nth place in line? N minus 1 place. Yeah? So that's how you do an explicit formula. Does that look? Let's see. So this is our first term, the 4, right? First term, right there. And the D is our common difference, isn't it? Or the 10 is our common difference. So it's 10 times the what? 10 times the previous, not term, but place. Right, or 1 less than it, okay? Does this look a little bit like y equals b plus mx? It's like ms plus b, mx plus b just switched around. Isn't the 10 our rate of change? Goes up by 10 every time, like slope, right? Isn't the 4 our y-intercept or starting point? Okay. Let's think about exercise 5 real quick. Seats in an amphitheater. Power pattern. So the seats kind of go around and they spread out, right? Yeah?
Yeah.
And it doesn't go all the way around the amphitheater, but anyway. So each row, I'll bet the row might be our place in line, yeah? Has a set number of seats more than the last row. Does that sound like an arithmetic sequence? Has a set number of seats more than the last row. Does that sound like a common difference? Or you just add some number? So this sounds arithmetic, yeah? The first row has 6. Hey, what does this sound like? Base of 1, the first term, right? Okay. And then the fourth term has what? 18. Doesn't it sound like they gave us the first term and the fourth term?
Yeah.
Okay. They want to know how many seats does the last row have, which is the 20th. So they want a sub 20. Let's write down what we know. What's a sub 1? 6. And then they also give us a sub 4, which equals 18. Do these look anything maybe like sample XYs? What's the input for this first term? What do we input?
1,
The place in line. What's the output?
6,
Down here, what's our input?
4,
The fourth place in line. What's the output? There's 18 seats or chairs, right? Yeah? Okay. Well, let's write something like this and see if we can figure out what we need the common difference, right? We need M and we need B, don't we? Do we know M, the rate of change in seats here? We don't. Do we know B, the starting number? Which is 6. Is this looking a little like MX plus B? And then a sample XY to plug in and solve for B, kind of?
So are we solving for 2, 3, and 20?
For what now? No, it just said they want the 20th. So let's do it this way. So let's give an explicit, A sub n equals, what's our starting? 6 plus some common difference. We don't know. D, right? D, we're about to do that. Is it D times its place in line? N?
D times n times.
It's D times the previous place in line, right? Because whatever that common difference is, we're going to add it one less time, right? You guys follow that?
Yeah.
This is our common difference. We don't know what it is. Up here we know it was 10. And up here we said we added 10 one less time than our place in line. Down here we don't know the common difference. But we know we're going to add it one less time than its place in line. So we have a 6. We know that's the A1, right? Well, do we have a sample N to put in here? 4, and what's the result? The result of putting in a 4 would be what? Would be 18, right? So our A sub n would be 18 equals 6 plus D times what?
N minus 1.
What's the n in this case? I'm plugging this in.
4.
4 minus 1. Yeah? Is this looking like we plug in a sample XY?
Yeah.
Okay. So let's go ahead and work this out. So 18 equals 6 plus what?
Plus 3D.
4 minus 1 is 3. It's just 3D. Can we solve this for D now, the common difference? So subtract 6. What do we got? Anybody can tell me what 18 minus 6 is? 12 equals 3D. What does D equal?
4.
D equals 4. So our common difference is what? 4. Can we now go write this explicit rule? Now that we know what that D is? What is our explicit rule? AN equals 6 plus what? 4 times n minus 1. Right? So now we have an explicit formula. Okay, this is explicit, not recursive. Which now looks like b plus mx kind of, right? What's there? Where do they get the what? The d? Okay. Well, now they want us to find the 20th term, where n equals 20, right? Yeah. So a sub 20 equals 6 plus
4
times,
minus 1.
right? What's 20 minus 1?
19.
So it's 6. Oh, I forgot the 4. I didn't write the 4. Plus 4 times 19, right? What's 4 times 19? 23? 4 times. Oh, well, think of it this way. What's 4 times?
76.
Yeah, what's 4 times 20, guys? 80. 4 less than 80. What? 76, right? All right, how many seats in the 20th row? 82. 82 seats, yeah? Okay. So that was an explicit one, right? The main idea here is D is the common difference, and remember, we add D one less time than the place in line, n minus 1. Okay? All right, let's go look at some Regents questions then. Yeah, look at the first one. We got some boxes there. Everyone read that over. On your own, read it over. So what is the thing of interest in these boxes here, guys? The shaded blocks, right? You want to know how many shaded blocks will be in figure 35. Wow. Well, they only gave us 3 figures. So it'd be nice to know what some of these terms are, wouldn't it?
A sub 1 equals 12.
So the first term is, there are 12 shaded blocks. So I'm going to put A1 equals 12, right? This would be term 2.
A sub 2 equals 16.
16. What's the third term?
A sub 3 equals
20.
Yep.
Okay.
We're just adding 4.
Yeah, is there a common difference, guys?
Yeah.
The common difference everybody sees is 4, right? So D equals 4, yeah? Okay. Now, if we did a recursive formula, we'd have to work it all out like, well, not 35, 32 more times, wouldn't we?
A sub 35.
Well, hold on, hang on. So let's see if we can get an explicit formula like we just did. You guys understand? Like the recursive formula says, here's the first term, here's a rule for finding each term. And remember how we found like the 4th term? We used that and we found the 2nd, and we found the 3rd, and then the 4th. Does that sound like it'll be really useful if they want us to find the 35th? Right? We have to do that 32 more times. But if we had an explicit function, we could just plug it in, couldn't we? 35 for the n? Okay, so n is, shut your yap for a minute. And I mean that as a compliment, right? So if I'm asking you to shut your yap, it usually means you know too much, right? And I got to let the other people think a little bit. So let's write an explicit formula. So it'd be an would be the first term plus our common difference times n minus 1, wouldn't it? Okay. Somebody other than Ennis. I think that looked like a 1. What's our common difference? Or what's our first term? Hannah, what's the first term in this? 12. Conklin, what's our D, our common difference? What do we add each time?
4.
Good job, Conklin. 4 times n minus 1. It's the same thing as adding over and over again. Look,
It'll just make it less sloppy.
where do they do it first? Like right here, like in this example, we added 10 3 times. Isn't that the same as saying 10 times 3? That means 10 times 3 means 10 plus 10 plus 10. 3 times, right? So let's just, so we multiply this number of times. It's the same as saying 4 plus 4 plus 4 plus 4 plus 4, whatever the number of times is, right? All right, so they want the 35th place in line. I'm going to let you guys finish this out. All right? Let me just finish this off. 4 times what, guys?
35.
35 minus 1, n minus 1. Right? I thought I left you just to pick up right where I left off there. Yeah.
I was going to answer. I got
Good.
it. My answer.
Yeah, and then
So you didn't get it. Did you do this?
yeah, I got 562.
No. You
No?
get 12 plus 136 to give you 148.
So A of 35, the 35th term is 12 plus 4 times what?
34.
34. What's 4 times 34?
136.
Well,
I missed that.
136. And you get what?
148.
148. I see.
That's what
You got it? All right. So some of you guys, I saw you doing the explicit and then trying to do like each term after. No, that's if you had a recursive. Again, that's why we didn't do recursive, because I don't want to do this 33 more times. Or 2, right? They only gave us 3. If you have a recursive formula, you have to find each term in the, along the line. But if we use an explicit, I could very easily plug in and find the 200th term. I just put a 200 in wherever there's an n. Right? Okay? And the common difference just gets added one less time than its place in line. That's why it's n minus 1. Okay? Whoops. Let's try number 2. Now it's back to recursive. Now they do this a little bit slightly differently, right? You notice they have an n plus 1 here? Okay, so that means what? What does n plus 1 mean? The next term. Can't write today. I think I mentioned that they might do that at some point. The next term. This is another valid way to do it. And so what they mean then by n, if they're talking about this being the next term, n would be what in this case? If n plus 1 is the next term, then what would you call the nth term? If the one after it is the next term, then it is the previous term. You guys see how n is the previous term the way they have this set up? Right? I mean, if you agree that n plus 1 is the next one, then n must be the previous one. So, there, you get that now? They give you the first term and a rule for finding each following term. Just a little bit different than the way we've been doing it, but I think maybe you get it. Okay. So they want the 4th term. No, this is not explicit. Remember, this is recursive. So they gave you the first term, then you got to find A2, and then A3, and then A4. That's why we didn't do it with the 35 in the previous problem, right? It's not that hard. We just can't subtract 7 a couple times?
No.
Just do it. Come on. Good grief. What's our first term? 5. Now go to the rule. How do we find the second term? What do we do? Oh, it was 2 times 5. So they mix it up a little here, didn't they? It was 2 times 5 minus 7. 3. Now find the third term. I'm going to let you guys do that. It's 2 times what? 3 minus 7. Keep going. Get to the fourth term. Nice. Hang it. Will, what do you think? Huh? I couldn't hear you.
I think I got there.
You got -9 for the fourth term? Anybody else get -9? You got -9? You got -9? Did you get -9? No, you didn't. Don't be sure.
I don't know how to do this.
What'd you get for this term, the third term? 2 times 3.
One.
Okay, what's 2 times 3? Minus 7. -1. Hey. But that's the third term. They wanted the what? Do that one more time. So a sub 4 would be 2 times what? Fourth term would be 2 times what? The previous term, -1 minus 7, which is -9. So a recursive formula is not that bad if you don't have to find like a huge term number, right? 4 is enough, 5 maybe, okay? On to 3. This is a little different, right? So this isn't really, it's not arithmetic, is it, by the way? Was this one arithmetic, number 2? It was not, it's geometric, right? Now they're getting crazy. But it's still just a rule. Is that recursive in number 3? Do they give you the first term? And then is that followed by a rule that gives you every term after? Okay. So the first term is, all they want's a second one, right? So recursive's fine here. Plug it in. Do you know the first term? What's the first term? Anna? What's the first term? Okay. And then what's the rule to getting each term after that? Take the what? What's this? N minus 1. What's that? The which term? Previous term. And doing what to it? Anna? What do I do to the previous term? No, that's squaring. And then, after I square it, then what do I do to it? Multiply by 2. If it was add to, it'd be, if it was adding to, it'd be a plus sign there. And after I do all that, then what do I do? Add 3. Okay. So if A1 is 6, we want A2. So A2 would be equal to 3 plus 2 times what? What's the previous term? If we want the second, 6 squared. What is that? The whole thing. 75, isn't it? Because this is 3 plus 2 times 36, right? Which is 3 plus what? 72, which is 75. Okay. Number 4, this should be a little easier. What are they asking there? So arithmetic means you do what to every single term to get the next one? Guys? Add or subtract something, right? Geometric means you multiply it, right? So you might check each, like above or below each, you know, did you do like +2 or ×2 or something? So check them all out. Find the ones of those 3 sequences that are arithmetic. Which ones just add something every single time, add the same thing every time, without multiplying. Is number 1 arithmetic, guys?
Yes.
Why? What's arithmetic about it? Isn't this just +2, +2, +2, right? So it has a common difference of 2. What about sequence 2? Is that arithmetic?
Multiplying by 2.
Oh, this is times 2. So we got that one is, right? Times 2, right? So not that one. What about the third one? A plus 2, yeah, is that, and then plus what? Another 2 to get 4, and then plus, right? So this is, isn't that arithmetic? You're adding the same thing every time, right? So it's choice 2. You're starting to catch on. Next page. Yeah, but these are getting easier now. Hey, there's a recursive formula. They give you the first term and the rule for finding the following terms. And if it's recursive, that you have to actually list them out, which they ask you to do anyway, right? So I would just do like this, A1, you already gave it to you, right? And A2, and A3, and then A4. We already know A1 is 3. So now just fill in, follow the rule to find the next term each time. What's the rule to find the next term? What's the rule, guys? 2 times what? What's this? Previous term plus 1. So you take the previous term plus 1 and then multiply it by 2. That's how you find the next term each time. So what's A2 would be 2 times what? What's the previous term? N minus 1? 3 plus 1, right? Which is 2 times what?
4.
Which is 8. And now that's your previous term when you go to the next one. Keep going. What's the third term?
2 times 8 plus 1.
I heard somebody say 18. Okay.
38.
So this would be 2 times 8 plus 1, which is 2 times 9, which is 18. And one more to go. You got 38? So it'd be 2 times 18 plus 1, 2 times 19, which is 38. And here's the ones they wanted. 8, 18, 38. All right. 6. I think there was a, oh, this is kind of a typo here. It's 6, guys. Actually, this is geometric. Let's skip it. But anyway, this shouldn't be a subscript. This should be 2.5 times an minus 1, like not like that. And this the same way, plus 1.5 times a and previous term. I don't know how it got like that. But let's skip 6 for now. Anyway. Let's go to 7.
I was so confused.
Look at 7. So the nth term. Do these choices look recursive or explicit? Do the choices here look recursive or explicit? Huh? Do they look like the stuff we did today, which was explicit? Do they look like this right here, maybe? This is explicit.
They don't.
Or do they look like this up here, which is recursive? Let's go look at it again. These look explicit, don't they?
Yeah.
Which means you have a common difference, but you multiply it one less time than its place in line. Okay? Let's think about what choice we would have here. First thing you need to find out is the common difference, don't you? The D. Well, that would be a common ratio, which is geometric.
Plus.
Couldn't use your calculator. Take the easy one. You can get from like
15.
okay, 3 to 18. How'd you get from negative 12 to 3? Are we just adding 15 each time? So plus 15, isn't that plus 15? And that's plus 15. So our common difference is 15. Right? So our thing would be A sub n equals our first term plus D times n minus 1, wouldn't it? On the previous page. So what's our choice? It's got to be choice 4, isn't it? So an equals our first term is negative 27. It's a starting point plus mx, 15 times n minus 1. One less time. You multiply it one less time than the term, so it's choice 4.
So is it asking for number 8? What the value?
Yeah, there's a typo there too. Value of, wait a minute. There's 2 typos. We're going to skip it. Anyway, that should be minus 1, right? Not up top. Wow.
Are you doing?
I don't know. This thing. So this should be 2 times a sub n minus 1 squared minus 1 at the end there. And then this should be right here as, should be a sub 5. But let's skip this one for now because we're running out of time. Okay, well, what do you got?
Well, I didn't finish it yet because there was 20 typos.
20 or 2.
Same number.
Yeah.